Okay, class, and this is a question that I posted in our discussion just to help us talk about irrational and complex solutions. And so in this situation right here, we are given two of our solutions. So we are trying to find a polynomial with rational coefficients, and two of the solutions are 4 and 2i. We have been asked to find any additional solutions and then find the polynomial. Now, if you remember, when we have a rational solution, all of our rational solutions travel completely by themselves. They do not have to have a partner. 4 stands all alone. We do not have to have its opposite because it is a rational solution. We're also told that 2i is one of our solutions. Now, 2i is a complex solution. That means it's imaginary because we've got our I in it. Complex solutions must have its opposite. That's also called its conjugate. So if 2i is a solution to my polynomial, negative 2i also has to be a solution to the polynomial. So because I am told in my original question that 2i is a solution, we immediately know that negative 2i has to also be a solution. So the solutions to my polynomial are 4, 2i, and negative 2i. So now we're asked to find the polynomial. So we have solutions. So here are our solutions. Now what I want us to do is I want us to identify the factors that are associated with those solutions. So if 4 is a solution, x minus 4 is a factor. Okay? If 2i is a solution, then x minus 2i is a factor. And if negative 2i is a solution, then x plus 2i is the factor. And then the way that we get our polynomial is that we multiply these 3 factors together to get our polynomial. And that is what we're going to do right now, is we're going to multiply those 3 together. Now, whenever you need to multiply conjugates together, if I've got x minus 2i and x plus 2i, I would always do that first. You could multiply x minus 4 times x minus 2i, but it will be ugly and it will be messy, and I do not recommend it. I recommend focusing on these first, whether they are complex like this with 2i and negative 2i, or whether they are irrational. So if you've got a square root and a negative square root, always multiply those two together first. You are going to be much happier. And let me show you why. When I multiply x minus 2i times x plus 2i, I'm doing the FOIL, so I have x times x. That gives me x squared. X times positive 2i is 2ix. Negative 2i times x is minus 2ix. And hopefully you noticed right there that we are going to be able to cancel those out. And that is what we want. We want to be able to do that. Then I have negative 2i and positive 2i. That gives me negative 4i squared. So right here are middle terms, and that is how conjugates work. They cancel. That's the difference of perfect squares. Okay? Then I'm left with negative 4i squared. I is the square root, I squared is negative 1. So I is the square root of negative 1, and I squared is negative 1. Okay, so we're going to take that I squared out, and we're going to have negative 4 times negative 1. That leaves me with x squared plus 4. So when I multiply my conjugates together, I minus 2i and I plus 2i, I'm left with a binomial, x squared plus 4. And that makes it much better for us when I multiply x minus 4 times x squared plus 4, because it's a binomial times a binomial, so I can still FOIL. X times x squared is x to the third. X times 4 is 4x. Negative 4 times x squared is minus 4x squared. Negative 4 plus 16, or negative 4 times 4 is negative 16. So I would rewrite this because you've got this x to the third plus 4x minus 4x squared minus 16. You almost always see it written with descending order of your exponents. So we have x to the third minus 4x squared minus 4, or plus 4x minus 16. Okay, so this is our polynomial that is associated with the factors x minus 4, x minus 2i, x plus 2i, and has solutions of 4, 2i, and negative 2i. Now, just to wrap our mind around all of that that's happening there, I want to show you the graph. So if you remember, solutions to this were 4, negative 2i, and positive 2i. And when I have something in the complex system of numbers, they do not cross the x-axis. Okay? They are imaginary. They are complex solutions. So here is the graph of this. So 4 is a rational, not irrational. 4 is a rational solution. So it's right there. It crosses the x-axis right there. My imaginary solutions, that's kind of dictated by this area of the graph right here. Okay, when you've got I anywhere in your solution, it's not going to cross the x-axis. Okay, so you are going to have behavior of the graph away from the x-axis, and that is how that works. So I know we weren't asked to graph it, but I always like to show the graph so that we can have a visual representation of what that looks like. So as always, if you get stuck or you need my help, let me know and I can help out.